Hello, my name is Sean Horton. I'm a student at JTech, and today I'm going to talk about starting systems and charging systems. So here we have a basic starting circuit drawn out with the switches closed. So you can see you have the battery right down here, grounded on one side. The other side has a fat cable going over to the starter motor. Then you have another line that goes up through some fuses up to the ignition switch. As you can see here, I positioned the ignition switch to the start position, which allows power to flow down into our relay there. When the relay has energy, which only happens when the clutch interlock is in the correct position, then that allows power to flow down to the starting solenoid. And when that has power, it closes the starter solenoid side, which allows power from that back cable to run directly to the starter motor. Next, we'll perform an open voltage test. We'll start off by isolating the battery, disconnecting it completely. I'm going to check the negative, the black lead, positive, the red lead. That's going to give our battery voltage. And we're doing this to see if it's any good, if we can get charged or not. Now I'm going to perform a voltage drop test on the battery cable leading to the starter. So you can see it jumped up to 300 millivolts, which is within the ROT. Our next we'll perform a voltage drop test across the negative side of the battery to the casing of the starter. So we're going to fire it up. You can see it jump to about 1 volt and then settle back down to about 300 millivolts. Now we're going to do a starter bench test. As you can see down here, we have the battery hooked up with jumper cables, and we have the negative side grounded out to the frame of the starter. Positive side over here where the incoming power goes. We have a little lead hooked up so we can jump the power to the solenoid signal terminal, and when I tap it, it's going to close the solenoid to allow power to pass straight on down to here into the starter motor. So start turning over here, and let's do that. And that is a bench test. So now we'll talk a bit about how a relay functions in your vehicle. When it's unpowered, there's no power going to the coil. And normally open relay, it'll be open, an outer limit reading on your DVOM if you would measure it. But as soon as it gets powered, the coil snaps closed, and you should have less than 100 millivolts for voltage drop. And you can see on this paper here, there's actually a few relays in there. And it's pretty imperative to control most functions on the vehicle. Here we have a disassembled alternator. It's got the alternator casing with bearings, the fan cooling. We have the rotor, which has north and south poles, the slip ring, which provides power to it, the stator, which is made up of coils of copper wire with 3 leads. Down here we have a voltage regulator, which provides the incoming voltage from the battery to the bushings, which provides the slip ring. And then we have the diodes and the rectifier bridge, which takes the power from the generated there and the coils and makes it DC again. Next, I'm going to do a voltage drop test on the alternator from the positive battery cable to the battery terminal on the alternator. See right there, it's about 200 millivolts. There's going to do a voltage drop test on the negative side of our alternator. We put one lead on the casing, a little bit on the ground. See right now we're running about 75 millivolts voltage drop. Next I'm going to perform an alternator ripple test. And I have the DVOM set to AC current. The negative side on the next battery, and put the positive one on the battery terminal. See right there, it's reading about 180 millivolts. And it's a ripple test with an oscilloscope. So you can see it reads a lot more information. It's a lot more customizable. And you can see we have a spike every now and again that's hitting right there. So there might be a problem going on with possibly one of our diodes.